large organizations has to use applications like enterprise resource planning, which is commonly called as ERP systems, and systems which talks to not just one computer, which talks to multiple computers, multiple servers, multiple different applications and so forth. Involves managing using many human resources. You need to have IT department to manage these type of things. So those type of solutions you can't do on your own. You need a team, and then you may be able to do small part of it as your project if you like, but then when you extract that part, it will belong to the previous level, because if you try to look at the problems of the full environment, it is too complex. Even to understand the background itself, you will find it difficult to comprehend during the period of time. So we are looking at small, the medium scale problems. Now, another thing I wanted to discuss is to use some common system analysis diagram, which is mainly used to show the interpretation of information when you talk to people, and how you try to understand something which you based on the information you gather, or based on the explanation of the client and things like that. Now, what the client try to explain, now the client will tell, I want a accounting package, and he will tell this is what you need, but then you don't know what accounting is. So you try to visualize what he is trying to say based on his description, and then what you have understood, then you try to put that into some program code, and then you come up with some solution. So usually what you understood won't be what is implemented, and what at the end what the client gets is something else. So that is what is trying to explain here. For example, this small sketch of somebody wanting to have some sort of seesaw design. Now he will explain that I want something hanging from a tree, and then someone to sit and move about in it. So the way the user explain, maybe the user will not assuming the explanation is like verbal collection, because the diagrammatic expression of the requirement comes much later, because this is a simple example. You may think you could have drawn it and given. It won't be the case when you get the requirements for a real world system from a client. Client will never give the design document for you to implement. He will tell here and there, this is what I need. So you have to interpret, you have to analyze. So what this says is, based on what was mentioned, when you analyze, you may think maybe this type of system what is needed, but then to get this working, you may have to do something like this or something like this, and then when you write it, you come up with something else, and then the end product is not the same as what was what the client wanted and things like that. So this is a common thing that happens in information system development life cycle, because the end users are not IT literate, so they don't know to think the way the IT people think. Similarly, the IT person is not literate in the business domain. So he doesn't know how to talk in the language the business person understands. So the two talk in two different languages. So it's like you go overseas and you try to talk to a Japanese person, and then he will tell something, you will tell something, but still you can communicate, and you will understand something, but not the exact thing what was communicated and what was understood. So the same thing what happens here as well. So so you should be aware of this thing, because you know what the computer can do, what technology can do, what others have solved through the solution, but client may not be aware of.
Right.
So you need to bridge the gap and deal with it in order when you are trying to solve this problem. Now, with the question I mentioned about the applications, I have listed a series of applications. There is generally no end when you try to think of areas that can be automated using computers. Basically, nowadays almost everything can be automated in some form, so that certain things can be done more efficiently using computers. Now, the idea of automation doesn't mean that you replace the manual procedure 100% and you say we don't want these people anymore, the computer will look after that.
Right.
That sort of thing won't be the end product. You still need some manual people to make sure that the computer runs the way you want and you give the input at the correct time and it happens and so forth. So you need some other people, but then you may not need the same amount of people, as well as you can do the same thing much quicker.
Right.
So if you are doing some will say a mathematical calculation to multiply and add and so forth, it takes time. But if you have a calculator, you can do it much quicker. Then if you have a program, then you say the input value, you get the output, which is even quicker. So the idea is, when you have some repetitive tasks, the best thing is to use this computer-based solution, so that the next time when you do it quicker. So although you spend more time for the first time to design and create the solution, you gain in the long run. So the possible applications, now the library, if you take those days, to find a book in the library, you have to have a catalog. So when you have a catalog, you have to write it in small cards and put in some sort of a cabinet, and then you have to arrange it in some alphabetical order, so that someone wants to know the book, he knows the author name, and then look at that letter and search that drawer. Nowadays it's in the computer, so that you not only author name, any small part of word, the computer will process and locate where that book is. So likewise, you introduce some solution where the task of processing or searching or whatever the requirement can be done in a more efficient manner. Now in a university environment, it can be a student information system or resource processing system and things like that. Or banking application can be managing customers' accounts, calculating interest, giving loans and various things. Then you have credit cards, how credit card transactions are done, the amounts are settled at the end. Then you have various billing systems, water, electricity and so forth. But then some other things, like if you say the electricity bill, now already there is a system to automate that. Now you have to come up with a solution not to reinvent the same thing which is already there. For example, if you try to come up with a electricity billing system for the Ceylon electricity board, then problem is, we know that it's already there. Why do you want to redo the same thing? Then you have to have some justification. Your justification can be, okay, they were using some old database, they were not using even a database, they were using some flat files. Because of that, these disadvantages are there. Now you are using some new technologies, new concepts to do it much better with more functionality. So if you are able to justify in that way, then reinventing another existing solution is acceptable. But you must be careful that these new things cover that 300-hour work. Because we assume that these things are there. You need less time for the system study, because already somebody else has done the study. So you are only implementing new things. So still you have to design how the new things will fit into the existing system or new environment and things. But if you can justify, it's no problem doing it. But if you take like a library example, libraries are used by many people. Now if you take your town, you will have a town public library, or a school will have a small library, or some society will have their own library, and so forth. So you can provide a library solution for many different type of users. Now again, you have to see the complexity, like I mentioned for this party